All right. So let's go over this topographic map thing. I am recording this. I'm going to post it online because, when you actually sit down to go through the lab, you might want to come back and reference this video because, to be honest, this lab's going to ask you to do some things that you haven't really done before. It's not hard necessarily. It's just going to take a little bit of concentration and of understanding of what the process is. And because we haven't gone over the process a lot, you'll probably want to refer back to the video to make sure that you're doing it right. I do have a couple maps that I'm going to get to you. I will pull one of them up in a second because I just want to show you one of the, I almost said Norman because I'm thinking about Oklahoma right now, but one of the Palmer maps that you can find pretty easily online. So let's see. The first thing, this is obviously not for y'all. You don't have homework. All right. So what is a topographic map? A topographic map is a map that shows the change in elevation through the use of contour lines. So all these little lines that are all over this map, these are called contour lines, and they basically show you the elevation. This map, I want to show you all this real quick before we get too deep into this. This is one of the cooler maps I've seen. They started doing these recently. They use plastic for the map, and they give it elevation along with the contour lines. So you can actually see, as you look at the contour lines, how the elevation rises. And so the thing I want you to look at as we pass this around is just take a look at the map, kind of see how cool it is, because it's a pretty cool map. This is in Tennessee. The title of the map is Knoxville, but Knoxville is actually up in the top left-hand corner, and it doesn't even look like the whole city's in the map. But yeah, so this is the Knoxville, Tennessee area. You got a couple other towns like Asheville. Wait, is Asheville North Carolina or Tennessee? I know. Is there an Asheville, Tennessee, maybe? Maybe it's North Carolina. Where's the state line at? I don't know. We'll have to look and see. Or maybe we won't. Who cares? Yeah, just take a look at this. Maybe pass it around a little bit and just see. The main thing I want you to see is in the mountains, you have a lot of those contour lines and they're really close together. When your contour lines are close together, that means you have a change in elevation, so some sort of steep slope. In the city parts where everything's a little bit more flat, you can see your contour lines are spaced further out. And so the further out they are, the more flat you're going to be. The closer they are bunched together, the more steep it's going to be, like a mountain range or a bunch of hills. So let's see what they go through here. Why study topographic maps? It's important for all sorts of geological work. Agriculture needs it a lot. If I'm farming or raising cattle, I need to know where the water is going to go on my land. When it rains a bunch, where's it going to lead to? Is it going to stay where I need it for my crops? Is it going to stay where I need it for my animals, or do I need to do something different? Environmental work is really big with topographic maps because most environmental work is determining where our pollution goes. So if a business or an accident spills a bunch of chemicals, if we don't clean those chemicals up fast enough, where are they going to go? What stream are they going to end up in? What area are they going to affect? And then also civil engineering. Topographic maps can help you figure out where's the best place to build your building or your complex or whatever it is you're trying to build. And that can be very, very helpful. Yes, that's a pretty neat map, huh? With the little mountains on it and everything. I bet they're pretty difficult to make. Nice. So let's see. And obviously, topographic maps are great for recreation and hiking. I don't know if I told y'all this, but one of my favorite things from high school, I got into ROTC, and I think I've told y'all about this. But we did this competition called, what was it? It wasn't just orienteering. It was like something orienteering. But I don't remember the first word. But anyways, it was like military orienteering. And so it's basically like a cross-country scavenger hunt race. So they put you in a field. with a punch card. It almost looked like a bingo card, like there was 9 spots. And I know there's more spots on a bingo card, but you had like roughly 9 spots. And then they basically say go, and everybody would start from the same point. And there's no track or course. You just literally run out into the field, and they give you a map. And on the map is your 9 different points, and you have to like run there. And wherever that point is, if you go and find it correctly, there's a stake in the ground with like a weird hole punch. It's not a normal round hole punch. It makes some weird shape so they know that you actually ran out there. And so basically, like the first person to run out and stamp all the spots and run back wins. And you can go any direction you want. You can get them in any order. It's just your ability to use a map and run to the point that you need to run to the fastest. And so it was actually a lot of fun. You get to spend a little bit of time by yourself. You'll be running and you're like, oh, am I even going the right way? And then you see some random person like run through the woods next to you, and you're like, maybe I'm in the right place. And it's just like a good day. And it, like, as someone who's always been a little heavier and didn't like to run a whole bunch, it's running without the express purpose of only running. You're running for some other purpose to like get a stamp or find something on a map. So it's like a slightly different motivation. But I remember that, and that was my favorite use of topographic maps. And anytime I go on a vacation and I plan on doing some hiking, I will look up the topographic map, because sometimes there's something cool like right over the hill, and you'd never see it because you don't want to climb the hill, or you're going that direction to a different hill. And if you look on the map, you're like, ooh, what is that weird thing? I'm going to go check that out. And you find something special and cool. So maps can always show you a kind of different view of the area that you're in. So the next thing we move to, important features on a map. The number one important feature is going to be a scale. Any good map will give you a scale. And this is essentially your relationship between a distance on the map and a distance in the real world. So if your scale, like they say, is 1 to 2,000, if I measure an inch on the map, in real life, that would be 2,000 inches. If it's a foot on the map, in real life, it would be 2,000 feet. That's my scale. So for example, this map has a scale down here at the bottom of 1 to 250,000. So 1 inch on the map is 250,000 inches in real life. And 250,000 inches doesn't mean anything to me, but I could convert that to feet and convert that to miles and figure out how much 1 inch is equal to in miles. And so that wouldn't be that bad. So you need to know your scale so you can actually get real life distances from your maps. You need to know which way is north. That's a common feature in all maps. This one has the north arrow where, I don't know if they're showing the north arrow. Even if there's not a north arrow, which most of the time there will be, almost all maps are made with north oriented up. And so if they're not telling you that directly on your map, you could probably assume that. And it might be here, I'm just missing it. But no, I don't see it. So maybe this one doesn't have a north arrow. But in the absence of a north arrow, I think it's safe to assume that north is up on your map. Different types of coordinate systems. And this is where we're going to get into the lab. We've all been introduced to latitude and longitude. We're familiar with it. It's the lines that you see on a globe. And just as a reminder, if this hasn't stuck yet, longitude has the word long in it. And so the lines of longitude are the ones that go from pole to pole. They're all the exact same length. They are long. They go from the North Pole to the South Pole. Those are your lines of longitude. Your lines of latitude are going to be your horizontal east-west lines. And the thing to remember about those, the one around the equator is very long. It goes around the entire Earth. But the ones up near the North Pole are actually very short. They're just tiny little circles around the North Pole and the South Pole. And so your lines of your lines of latitude are different lengths. Some of them are long, but some of them are short. The other thing I remember Never mind. I use another thing to remember it, but it's not relevant today because it's like a 90s thing. So let's see, latitude and longitude. The other way to do this is township and range. And township and range, because we don't use it very much in like lower grades of school, we really don't use it that much at all. It's weird, and it takes a little bit of getting used to, and this lab is going to try to teach it to you in a way. Know that it's almost purely an American thing. I don't know that any other countries use this mapping system, but apparently a lot of our towns and cities and states are designed around the township and range system, and so we're gonna go over that, and we're gonna try to learn that a little bit, and the lab is gonna walk you through it. So let's see. Important features, they're showing you the scale here. So this is a good example of a scale. This one is 1 to 24,000. So you know an inch on my actual map is going to be 24,000 inches in real life. Or they also have the scales down here. So if I just want to measure a distance on the map, I take that same distance and I come down here to the scale, and it should tell me how much it is in either miles, feet, or kilometers. So I got 3 different scales tell me with my 3 different distances. So you want to make sure that you're using that. Another thing the map is telling me right off the bat, which will help, my contour interval. And that's essentially how many feet of elevation change is in between all these little lines that are on the map. So the contour lines that we talked about, how many feet? Is from one line to another 20 feet? Is it 10 feet? Is it 50 feet? That will change depending on the map. So you want to look at that. So that kind of helps you understand where the lines are at. Let's see, what else? These maps have a bunch of information that you don't necessarily need, but can be kind of helpful. So they'll have a date on the map. I don't know if that's true, 1929, but if your map is from 1929, you might expect it to be at least a little bit outdated, especially with the man-made features, but definitely with the natural features as well. So what do they got here? Here's her north arrow for the map that she's using. So it's showing you north, and it even has a couple angles here. So she's got the north arrow with the star, and then she's got a slight angle for GN, which I assume is grid north. I don't know what the GN is. And then they have MN, which is magnetic north. Yeah, it says grid north maybe. So I don't know what the grid north is, but the magnetic north is showing you the difference between a compass north and a true north. And so there's lots of information on any good map that you find. If you get a map and it's not very good information, that's going to make more confusion. So here they're just showing you can measure the distance on the actual map, bring it down to the scale, and know that here this distance on the map is roughly what, a half a mile. Yeah.
Just says it defines like where it is on the grid north.
Grid north. Okay. Yeah. So the map. I guess what they're trying to say is the squares. Yes, you can see this. The squares on this map are not like parallel to the map itself. You start with a small space over here, and then as it gets over here, that space gets bigger and bigger. So these north grid lines are slightly tilted to the right, like you see here in the north section. So yeah, it's your grid lines. Let's see, what else? All right, township and range sections. And basically, I think, is this right? Yes. No, this is latitude and longitude and not township and range. That's okay. Okay, so here's how this works. It's really weird, and it takes a little getting used to, but your township and range is basically like a square grid, and every square has a certain number and designation based on like an X and a Y axis. The weird part is the X and the Y axis don't start at the bottom like a graph. They actually start in the middle. So you can see here, you have your this would be Y, right? Your Y-axis vertical, then your X-axis over here. And I have townships and ranges both above and below both of those. So it kind of goes out in all directions from your central kind of cross here. So what they say, each township and range is divided into 36 sections. So you can see here, once you get into a smaller township and range, they expand that out over here and they divide it into 36 sections. And another one of the weird things is it snakes back and forth. So it doesn't read from left to right or go down like we're reading a book, but it's going to start at 1 right here, and it's going to move 1, 2, 3, 4, 5, 6, and it's going to snake down 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and it just snakes back and forth all the way until it gets to 36. So this is a weird numbering system inside a weird kind of grid system. Now, how the township and range goes, which I think they'll show us right now. You have your baseline with your two different lines. The baseline is your left to right line. Your principal meridian is your north to south line. And they're going to separate your townships and ranges. So you can see above the baseline, we start to count the townships. So if I go north of the baseline, I get to township 1 north. And you can see that all of these are 1 north. And so I'm going up 1 block, and it's telling me what direction I'm going in that block north. And if I go up another block, I get to township 2 north. And so I'm literally just counting how many blocks I'm going in that direction. If I go south of the baseline, I get to township 1 south. If I go south again, I get to township 2 south, and it'll just keep going and keep going. The principal meridian is going to be the same thing, but instead of township, it's going to be range, and instead of north and south, it's going to be east and west. So you can see going east from the principal meridian line, I get range 1 east on all these. If I go east again, I get range 2 east. If I start from the principal meridian and go west, I get range 1 west and then range 2 west. And so this is a really weird system. Can everybody agree with that? Like looking at a map, it's not like easily understandable and you're like, oh yeah, I got this. So when you get to this part on the lab packet, definitely come back and watch this video, and at least this part of the video, and try to get an understanding of what this is going. But basically what they're going to do is they're going to give you like a blank version of this and just ask you to write everything in. And then they're going to have a couple symbols here and there that are going to ask you, like if I had an actual map and there was like an X right here, what would be the township and what would be the range and what would be the actual, what do they call these now? I'm sorry, we'll get to this in a second. But they have a specific name for these. Yeah, maybe sections. Does it say that here somewhere? Okay, cool. Yes, those are your sections. Yeah, 36 sections. There you go. If I just kept hitting the button, I would have been fine. But yes, so I guess also this is another weird thing. Every township and range is 6 miles by 6 miles. Every section is 1 mile by 1 mile. So you can see this is definitely an American thing because there's not even that many countries that use miles. And so they definitely won't have a system like our township and range system. So here's something similar to what you're going to see on the lab. The lab will be a little bit different, but this is what it is. So you have, I assume, some sort of county here, maybe a couple counties. You have the Arkansas River. They have a word Fort and a word Hodgman. These are either going to be towns or counties. Within this map, you have this one square that they're pulling out of. And so I can see that this is Township 23 South. I don't even see the baseline or the prime meridian line, but they have it labeled here. So this whole row is Township 23 South. And up top here, this is range 21 West. If I count over to 26, I go 21, 22, 23. So this will be range 23 West. So now I know that this square is Township 23 South and range 23 west. So I know my township and range. Then I look in here and I see my 36 squares. I know that the next blow up they have is going to be from square number 21 or section number 21. So it's township 23 south, range 23 west, section 21. And now in this is where maybe we shouldn't even be doing this. I remember this being kind of fun because it's like a puzzle to get, but the more I explain it, the more convoluted it is, and you're like, oh God. But we'll see. We'll see if we can make it through it. For each section, you can split that into 4 quadrants, and the quadrants are going to go just by direction. So this would be the northeast quadrant, northwest quadrant, southwest quadrant, southeast quadrant. So north, south, east, west, 4 quarters. And then in each one of those, you can split that into 4 more directions: northeast, northwest, southwest, southeast. So let's say, for example, I had a point right here. We already know it's going to be township 23 south, range 23 west, section 21, and then it's going to be in the northeast quadrant of the northeast quadrant. So that's what they have here. Well, actually, they're using letters. The lab might actually ask you to use the directions instead of the letters. But you can see that it is, why is it A, C? Oh, they split that one again. Okay. I don't know that the lab has you split that one again and do 3 directions. The lab might just have you do 2. In fact, I'm pretty sure it only has you do 2. But you can see it's getting a little convoluted. And so if we were using directions, this would be northeast, and then what? Southwest inside that block. So you're in the northeast block of 21. You're in the northeast block of that northeast block, and then the southeast block of that second northeast block or southwest block. And so, yes, it gets very confusing very quickly. And I remember the lab being a little bit frustrating, but also fun to do. So we'll see how this works out. Now we get to latitude and longitude. And thankfully, this is something we're a little bit more familiar with. Obviously, your latitude, like I said, is your horizontal lines. Your biggest one is going to be at the equator, and then they get smaller and smaller and smaller as they get away from the equator. Longitude is going to be your vertical lines on the map from North Pole to South Pole. And remember, it doesn't matter which way you go. The North Pole and South Pole are always the same distance. And so all your lines of longitude are the same distance. They're all long. So they have their example here. Here's how this works if you haven't gone over it in detail. The Earth is essentially a globe, right? Obviously it's a globe. It's a sphere. And that sphere from the top is based on 360 degrees, like all the way around, right? And so when they divide this up, as you divide up your lines of latitude and longitude, they divide it up, and I don't remember exactly why this is. They divide them up into 60-minute degrees. And so the way they give latitude and longitude, if you haven't used it before, the little single, what is this? It's not a parentheses. What is this? What is it? But it's not a quotation. It's not. Yes, is that it? Yes, apostrophe. Yeah. Woo, it's been a while. So yeah, if you have one apostrophe, that actually means minutes. And if you have the double apostrophe or the quotation mark, that actually means seconds. Here's the seconds. And so know that there are, just like time, 60 seconds in every minute and 60 minutes in every degree of latitude or longitude. So that's how we break down the little boxes that the latitudes and longitudes make, is we break them down into minutes and seconds. So if you ever hear anyone read out a latitude and longitude coordinate, it will have minutes and seconds in it. This is just a picture showing you latitudes and longitudes. These are your lines of latitude. Those are your lines of longitude. The prime meridian is your main line of longitude. This is what separates, I guess this is the timeline, right? This is what separates the days, I think. So your prime meridian here, correct me if I'm wrong. And then your main line of latitude is always going to be the equator. It's your base one that we build off of. So from the prime meridian, you're separating your east and west lines of longitude. Okay, now we get into contour lines, and we started off the PowerPoint talking about the contour lines. These are your lines of elevation on your map, and they're just showing you a couple things. The thick lines are going to be like your index lines that show you your bigger numbers. So if you see a thick one, it's probably going to be a round number like 800 or 1,000 or something big. And then in between, they may not even be marked. So like here, I go from 800 to 700. I can just count this out and go 700, 720, 740, 760, 780, 800. And so by counting these, I can tell that they're 20 meters apart or 20 feet or whatever that happens to be. But if I went down to the bottom of the map, it would also tell me that your contour lines are 20 feet apart or 20 meters. Now, one of the things the map is going to do is to ask you to draw contour intervals. Sometimes this will be kind of easy. Sometimes it will be kind of hard. But I want you to kind of see the process. So the one thing to remember about contour intervals is, oh, that is not good. What's going on? Oh, they're showing you how to do it wrong. The contour interval has to account for just one elevation. So the idea on one of these maps, if I get a map and I'm standing on a contour interval and I just follow that contour interval on the map, I will ideally never walk uphill or downhill. I might take a really strange route where I'm going, but I will stay at the same elevation as long as I'm walking on that contour line. So for that reason, you can't have contour lines cross at all. And you want to make sure that your contour line kind of makes sense with all the other numbers around. So like here, my 400 contour line leaves and it goes through 401. That's okay. They're really close together. I wouldn't be too mad about that. But it goes right through 410. And now I know that there's a problem because 410 and 400 are not the same. So this line should have come around 410 and not gone all the way through it. And so what you want to do with your contour lines is separate things that are higher and lower than your number. So for example, we got our 400 one. Pretty much every single number other than 398 is bigger than 400. So that's what I'm doing. As I go around 400, I'm separating the numbers that are bigger and smaller. All my bigger numbers are inside my 400 loop. All my smaller numbers are outside. Same thing with 410. Now with 410, I have some more mixing that's going on. So I only have 3 numbers that are bigger than 410, and I have 4 numbers that are smaller, and they're all separated by that line. So the 410 line only goes through the number that's actually 410, and it's going to circle around everything else and kind of separate them out. And then I don't have an actual 420 line, but I know that I'm going by 10s here. I've kind of made that decision myself. And so I know that 420 is in between 410 and 421. It's going to be a small circle right around here. And so what this is showing is a hill. This is just a basic hill. This is the peak of my hill at the very top. And if I go down in any direction, I'm going to go downhill. Now, if I want an easy trip, I will go this direction because this is a gentle slope. I have to travel quite a bit of ways before I get all the way down to 400. If I go this way, I only have a short distance to travel before I get down to 400. That's going to be more of a steep slope or hill coming down here. And so just by looking at how close the lines are versus how far away they are, I can see where my steep hill is and where my gentle sloping hill is based on the lines. Here's one with streams. This is actually going to be a little bit difficult. I didn't think about this. So we might work on this for a while because I don't want to overload y'all. I want to make sure everybody kind of gets what's going on here. So real quick with this one, I believe they will show you, they will ask you to do one of these. It's not too bad. Basically, they're going to give you a map. I don't remember if the one in your lab actually has the lines on it already or not. Let's see what we're talking about here. So this is going to be, if I can find it. My fingers don't want to open the pages today. Yes, so you're going to do both of these at once. So turn to page 147. And basically, they have a little bit of this started for you. But they have a topographic map with only one contour on there. You're going to have to fill in the rest of the contours. So you see all the different elevation numbers. The kind of V line that starts in the very middle and splits off and goes left and right, almost like a little fork, that's actually a river. So I will go into this a little bit more detail probably tomorrow. We'll do it on the board. But that's a little river, and you can see the contour line that's marked 100. And if you look at the map, that contour line separates everything that's above 100 and everything that's below 100. I just have a pen fall out of my pocket or something. That's weird. And so if you follow that 100 line, everything to the outside of it is over 100, and everything inside that 100 line is under 100. So it's a nice starting point. So what you're going to do is fill in the rest of the topographic lines and kind of create this map in a way. And when you get done, this is actually not too hard to do. They have this A to A prime line. On the board here, it's A to B, but on your lab, it's A to A prime. So once you get all the lines filled in, you're basically going to go from left to right. And anytime you cross one of your contour lines, you're going to see what elevation is that contour line. So I leave A. The first line I cross is 20 meters, right? So I'm going to come straight down. I'm going to use a ruler. You won't make like the dotted lines on your lab, but you'll just come straight down here. And when you get to this bottom chart, you're going to mark whatever elevation it is you crossed at that line. So here I crossed 20-meter line. I'm going to come down at that particular left-right point and mark 20 meters. I haven't started my line here yet. I'm just putting like dots. So I put a dot here for 20 meters. I keep going till I pass the 30-meter mark. I come down here and put a dot for 30 meters. Keep going. I pass the 40-meter mark here, and then I pass it again right here. And then every time I pass a line, I come down and I make a mark. And that's what they're doing every single time with the dotted lines. They make a mark. At the end, I have a bunch of dots here. And literally all you do is just connect the dots and kind of draw a line that shows what you're doing. And so what this is doing is showing my map from the side. So what I have here are two hills. Down here, I'm at the bottom of the hills at 10 meters. And then I go up the hill to 40. This one's a little bit higher of a hill at 50. And you can see as I travel along this line, I go from 40 down into the 20s and back up to the 50s. So I have two separate hills right here that I'm climbing up. And you can kind of see that profile. I come up to the top of this hill. I go down again. I come up to the top of this hill, which is a little bit higher. And then I go down again. So I'm kind of building this profile out of the data that I already have. So you're going to do one of those also and answer some questions on it. But I don't think that's going to be too bad. I really, really don't. So let's see. We'll stop here today. It's almost time to go, right? I feel like we've been talking for a while. Yeah. And if you want to start working on this, go ahead and start working on it. Don't forget we have those other two assignments on Pearson that are open. They're open until Monday. Obviously, if you need an extension on that, let me know. But tomorrow, I will have like a little digital version of the lab, and we'll start to work through it, and I'll kind of show you what's going on and how we're going to work some of these problems. So hopefully we can get to a point where everybody feels comfortable with it, especially the township and range part. I feel like that one, I remember that one being the most confusing to me. All right, so thank you.